Welcome everybody to this webinar. This webinar was generated totally out of the blue, and I was told by our sales team who was in Houston. They told me, we need to do something, and we need to talk about something that you like, but it's new because we always do things about industries and do insurance. We've done data centers, we've done mining, etc. And this is a topic that I hope it's going to be interesting for all of us, as normally we have to interview, or sometimes we are the experts and we have to transfer this knowledge to the people that are building the model. Or sometimes we are the ones building the model ourselves, right? So that's what we're going to talk about today, right? How is it that we go from gut feeling, right, from knowing more or less what happens, to a Monte Carlo simulation, right, to go the whole process until we get it to work. This is something that we're going to go step by step. You can use the chat, you can use the Q&A, and if you have a very long question, please let me know, and I will have the microphone open for you. So thanks again for coming. I see again familiar faces. This is home for you. Please feel free to chime in anytime, right? So a little bit about the roadmap that we're going to have today. First of all, this roadmap and this process is designed for new audiences, right? So we go, remember, simple intuition first, then technical rigor, right? This is for new audiences. And we're going to start with typical business question, right? After we have the question, like for example, are we going to make this project or not? Is the NPV positive or not? Is the cost estimation enough for the budget that we have, or maybe we're overshooting that? Do we have the right uncertain drivers, like for example, which inputs are not fixed, right? How much we have in CapEx, right? How much we have in CapEx, how much we have in our, commissions, in our revenue, etc., etc. So what is it that, which inputs are not fixed? And this is a very important question, right? We're going to see that in a minute. We're going to turn when we have the drivers, we're going to do something that's called expert elicitation, which is basically extract from all of you guys, from all the experts, this information into estimates. Then once we have these estimates, once we have the parameters, right, we're going to move from a world where we have a task A that lasts maybe 10 days, and we're going to move to a world where that task is now task A, and now it is between 7, 10, and 14 days. So when we have this expert elicitation, when we have these estimates, now we have to choose a defensible shape, right? We're going to do, this is a cycle, right? And it's always a retrofitting cycle that's going to say, well, have we met, or are we with the correct distribution or not? Then once we have the correct distribution, we're going to feed it into this Monte Carlo model, right? In this mathematical blender that is going to generate samples from each one of these distributions that we will use, and then we'll make the decision, right? Always, you see, all these models, the main idea is to give you and to enrich your decision-making process. That's the main idea of the process, right? So this presentation is built with practical modeling actions in mind, right? I didn't want to do something very philosophical, because I know it's really nice to have these discussions, these philosophical discussions, but we like to do things. And in this one in particular, I wanted for people to take this and hopefully go to their tool of choice and perform it, right? So the goal is to have, and this is the goal of today, right? To have better decisions and not only mathematical decoration, right? And we were talking I was in a training half an hour ago, and we were talking about the illusion of having a very complete model, right? We took 2 or 3 days to build the model, and perhaps we think because of that, because it's so complete, we think it's super complete, it's going to be okay. And that's the mathematical decoration, right? We have a lot of formulas, we have a lot of things, but if you go inside, if you double click, it's not good. Now, what is the issue with gut feeling? And this is what I wanted to picture there, like this children movie, right? When you have all these feelings there, it's the same, right? Gut feeling is this. Gut feeling is when if you're in the right mood, maybe your estimation is going to be, well, a very precise one is going to be good. But if you're tired, if you're sad, if you're very happy, if you're excited, if you're sick, etc., this all goes into the gut feeling estimation. And there are a couple of books. I mean, there are thousands of books on the topic. I remember one that it's called like, well, it's about the market traders, right? And how their decision making is so blurred when they are too tired, when they are too tired because, hangover, or they are too tired because of sports, whether it's Friday, whether it's a Monday, whether they are happy, etc. And they actually read and actually go through this and analyze what gut feeling does it to the decision making. So what we want to do is want to hopefully move to a structured judgment, right? A structured judgment that is going to tell us, well, how is it that we're going to take aside and we're going to abstract from all these things, which I know that we don't want to discard that because we're human beings, right? But at the same time, we have things to do. We have to build things. We have to build processes, build companies, tunnels, I don't know, data centers, everything that we do in our industry webinars. We have to do that, and this cannot be overlap too much by the gut feeling. So that's why we wanted to do this process. And then hopefully, if we succeed doing this, right, then we can move to the Monte Carlo simulation that's going to convert all this structure uncertainty into a range of possible outcomes and using all the drivers that matter the most. So we're going to have new ways of taking a look to the results, plus we're going to see which are the main variables, right? So we don't want to replace expert judgment, right? We want to discipline it a little bit so it's not as abstract, as subjective as it is. So we're going to move at the same time. See, we have this, right? This is our main assumption, that we're going to leave aside a little bit gut feeling, and we're going to include that into our model. Then we're going to move from a world where we have one value per input. This is the typical Excel sheet, right? When we have revenue 100, cost 80, NPV equal 20. Of course, super simple. That it's easy to explain, but dangerously precise, right? These are the typical Excel models. So as I said, the illusion of completeness, right? It's very common, it's very usual. And we're going to move to a world of ranges and distribution. This world of ranges, right, we're going to replace all the fixed inputs with uncertainty. The uncertainties are going to come into ranges, right? The ranges are going to feed, the ranges are going to be inputs for this process. Remember the process that we call Monte Carlo simulation. This process is going to recalculate the model thousands of times with random numbers from these ranges, and we're going to generate an NPV, which is going to be a distribution again. So this is the main change in the paradigm, right? One is that we're going to move from the gut feeling to the structured judgment. And when we're there, we're going to move from the deterministic to the probabilistic model, right? That's the main idea of the model today. Now, what is it that Monte Carlo simulation produces, right? As I said, you have input distributions, right? The ones that coming from here, the revenue, the cost, the commission, yeah, inflation sometimes, it depends on who's modeling. For each input distribution, right, let's say that we have 1 or 2, you can have 2,000, right? For each one of them, we have something that it's called the random sampling. That means that in iteration number 1, I'm going to take these 3 random samples and recalculate it. And this is going to be result number 1. Then we have another sample here for each one of them, and it's going to be result 2. Etc., until we do this 10,000 times, right? We're going to have 10,000 results, right? So the model is recalculating it 10,000 times, and we're going to have what we call an output distribution that we're going to see in a minute. Once we have the output distribution, we're going to see what we call a sensitivity analysis, a tornado chart that is going to show us exactly which are the main drivers of my model, right? So Monte Carlo is going to be able to answer. Imagine, you cannot do this with a simple Excel sheet, with a simple numerical model. It's how likely is it that something could happen, and what is driving it? The what is driving you can do. There are some techniques that you can do, but how likely, bringing probability to the table, is very difficult. So what you will get after you run the simulation is this, right? You will get an NPV distribution, for example. that's going to say, for example, that you have your 0 here, and it says that you have 10% probability of your NPV being negative, right? NPV being negative, meaning that you have 10% probability that you're not going to do the project, right? That it's going to be very risky because you already included the risk as the discount rate. Or this could be a cost estimation, and this cost estimation would say for P90, it's $5 million. $1 million. That means that you have 90% probability that your cost is going to be less than $5 million. Right? Now you know we're talking in the budgeting time, and this could be time if you're talking logistic, or this could be, I don't know, medium time between failures, etc. So this is one. This is the output distribution, and the second one is the sensitivity. And the sensitivity normally is represented by tornado charts, and these tornado charts are going to show you which are the main variables that you have in the model. Why is it that you like this? Why is it that we need to have this? Because this is going to give us focus, right? This is going to help us with the allocation of resources. It's going to help us with priorities, right? That's why we have the sensitivity. So if you say, why is it that we're going into this mess of Monte Carlo simulation? Because Monte Carlo simulation is going to think in ranges, as it says below. It's going to express this in confidence levels, as I showed you before with the NPV and the cost estimation, and it's going to give us the drivers. The drivers, in that case, are the main uncertainties which deserve management attention, the priority that I was talking about before, right? So these are the three things that I rescue as the main things that Monte Carlo brings into the table. Now, let's translate our intuition into ranges now that we have the general framework, right? First of all, where is my uncertainty located? You have to think about it, and it is very important because most of the time we say everything is uncertain, right? When you say everything is uncertain and you have a financial model for an energy project, you will have 3,000 variables. You will have 200 variables. It's way too much. You will say, maybe this is, oh my, we have to do an analysis of 200 variables for 200 distributions. And then you will have to ask yourself, which are the main variables of the model? And these variables could be, as it says here, cost drivers, schedule drivers, revenue drivers, financial drivers, etc. So what is it that is going to be the main affecting drivers to the model? Once you have that, normally you see uncertainty. Then uncertainty is not everywhere because, of course, I mean, it could happen that the inflation rate is going to change, but a little bit, but not that much. It could be that the exchange rate is going to change, but maybe you're in a very stable country, if that exists anymore. And then the exchange rate is not going to change a lot. So these are the types of things that we have to know. You as you are the expert, and as the expert, you will know when uncertainty is very important and it's not very important in other things, right? So once you identified where are your drivers, now you go from the intuition that you have on the drivers to the model input, right? And you will start with something like this, right? The experience is that if you say, well, how long, right? How long does take task A, maybe, I don't know, painting a room, putting some coating there for water or something like that, right? So what is going to be my in this case, the length of the task? This would say maybe 15 days. And normally, if this is the estimation that your provider did, you will say, maybe, this usually takes longer because this and that. This is when your experience comes into place. And then why, when, and under what conditions? Because this could be that you say that this could be 20 days as the average because you've done it, I don't know, 120 times. But sometimes you have some risks that should be added, right? The risk of, I don't know, heavy winds, or the risk of the bad quality, of the risk of interruptions from the site, etc., etc. Then you go to your estimates, right? Remember, your estimates can be, the lower bound would be 12 days, because I know I could do this in 12 days. 15 days could be the most likely, and maybe 27 days could be under regular conditions. That these are the three, minimum, most likely, maximum, or P10, P50, and P90, right? So these are the three limits that you could define. Now, Once you define the limits, then you can define the distribution, because one distribution can be like this. Another distribution can be like this with the same limits. Another distribution can be like this, right? Depending on the behavior of the variable. Once you define that, you will translate that into a formula in Excel or in Model Risk, which is the software that we prefer, right? So each one of these steps, and this is the key here, and I don't want to go deep into the process, but this one, I know it's very important. Hopefully you can document every step of the way. Otherwise, you will go into what we call the black box modeling, which is, why is it that, for example, Jameson chose this distribution and you don't know why? You don't know what was it that he did. So of course, because he's the expert, but maybe sometimes it's not enough. So the best distribution that you're going to apply, is the one that transparently captures the expert belief and available data, right? So this is the part of the intuition to the input models. And we have two sources. And in 2 minutes, we're going to do an exercise. So what I will ask is if you can open a notepad, right? Or if you can open, pen and paper, because we're going to answer some of the questions, right? Some of questions to do the expert elicitation. So we have two potential roads here. One is expert-only elicitation, is that you don't have reliable data, right? For example, I working with the nuclear industry, I remember a few years ago, they were inventing things that they never existed before. So they didn't have reliable data. This was the first or the second time somebody was doing this, right? So you can have structure estimates. Remember, we moved from gut feeling to structure estimates to parameterize the distribution and validate the percentiles, new technology, unusual procurements, regulatory risk, etc. And then section number 2, you're lucky enough, you have data. If you work in the financial industry, if you have temperature logs, downtime history, maintenance records, etc., of course, you're very lucky, you can have a distribution fitting. We have in our YouTube channel a complete video about distribution fitting, but I will do a very simple exercise today, right? So remember, these are the two sources of uncertainty quantification. Now, let's do the first one, right? The expert elicitation. In the expert elicitation, we're going to convert the experience of somebody into usable inputs. And as we know, the Monte Carlo simulation models are only good as the uncertainty behind them. So the elicitation process is going to make expert judgment consistent and useful. Now, we're going to do two things here. One, we're going to calibrate each one of us, right? This is something that we always need to do. Why is that? Because maybe, well, I'm going to take some names, right? Maybe Alice likes to have very wide ranges, right? She likes to, to be very, very defensive in the estimations, but maybe, I don't know, Enrique wants to do less, right? He's very narrow because he knows about that. So we need to calibrate that. To calibrate that, we're going to show you a series of questions, and please take a look to each one of them. I already did the exercise, and I know my accuracy, my calibration index. And after that, after the calibration index, we're going to use it with another model, right? So this is what we're going to do right now. So please, Jameson and Dan, please do it with me as well, because it's a fun exercise. And the main idea of this exercise is to see how wide or narrow are the ranges that you normally come up with. And to do that, and this is one recommendation I got from a friend years ago, years ago, and I've seen it in a couple of books. And as with every methodology, it has its pros and cons, right? Is that we're going to see how good are we doing estimations, right? So I'm going to show you 10 questions. And for these 10 questions, I'm going to give you 3 to 4 minutes so you can answer all of them. Of course, I'm not going to show the answers yet. And please don't look it up in Google or in ChatGPT or anything like that. The idea is for us to generate ranges that are going to include the value. For example, here, if you say, what's the population of Brazil, right? I don't know for sure, but population of Brazil. Right? So you can say it's between 50, this is the low, right? and 350 million, right? So if I know that it's like 250 million. No, well, somebody, I think Enrique is here, so maybe he can help me, but it's like 250, 200 plus millions. So the answer, the answer is inside of the range, right? But you see that the ranges that I gave were very, very wide, right? So I'm going to simplify the method, and I'm going to give you this. Here you go. Enrique is going to send us the real number, right? But the main idea here is that, here you go, 200, 250 million. So the main idea is that for all these questions that I have here, right, we're going to create ranges, right? So let's go with the first one. And I'm going to use maybe Jameson or Dan, if you can write down into the chat that you're okay, right? Not that the answer, right? So what is the height of the Eiffel Tower, right, in meters? Right, I'm going to count to 10, more or less. So you put it in a piece of paper or in a notepad with 1, 2, 3, 4, 5, and then I'm going to show the answers later. So don't worry, you don't need to enter the answers, right? Second question. What's the population of Tokyo in Japan, right? You need to define a low and a high for each one of them. A low and a high, right? Low and high, like this, right? Number 3. This was something that helped maybe the whole humanity, right? Which was the year that where Google was founded, right? Again, a range. Of course, if you say from 1900 to 2026, of course you will make it happen, but it's too wide, right? Number 4, right? What is the length of the Amazon River in kilometers? You see, the Amazon River almost crosses all of South America, right? Right. Number 5. What is the current annual inflation rate in Switzerland? I know this one because I have a really good client there, and it's a good friend, but he's not here, and I'm not going to say it. But this is, for example, a stable country. Remember that we were talking about? Hey, but Gatsby, please don't include the estimations in the chat, right? You should do it for yourself only. No need to put it in the chat. Thank you. Right? What is the market capitalization of Apple? Right? No worries, Gatsby, no worries. It's fine. You should do it for yourself. It's totally fine. It's not like you blew up like a super difficult exercise. No. It's just for you to see how good are you estimating things. Thank you. No problem. Right? Number 7. How many countries are members of the United Nations? Right? Right. Number 8. What is the average life expectancy in Japan? Right, one of the highest in the world. You want to live forever, you go to Japan. Right. Number 9. What is the distance from the Earth to the Moon in kilometers?
Oh, I know it in miles, but
oh, now you have to translate it. There you go. Multiply it divided by 1.6. Okay, multipy it. I guess so.
My old Saab.
A mile is 1.6. Here you go. And the last one. What's the global annual production of crude oil in millions of barrels? You see the crude oil that it's now having a very difficult year so far, right? What's the global annual production of crude oil? Right? So now that we have this, right? Now that we have all these questions, the idea is that you wrote it down, right? And you see, I'm going to unveil, right, the answers, right, which are there, right? So the Eiffel Tower measures 330 meters. Tokyo has 40 million people almost. Google, thank you, Gatsby, you have 1998. The Amazon River measures 6,500 kilometers. The inflation in Switzerland is 1.5. 3 trillion for Apple, more or less. Of course, it oscillates. 193 countries, 84 years in Japan. Earth Moon distance, you go 384,000 kilometers, and you have 100 million barrels per year, right? So what's the idea, and how is it that you're going to define yourself, right? If your low estimate was below the true value, and the true value was below your high estimate, like for example, if you said 250 meters to 750 meters, right? You receive 1 point. Why is that? Because your range included the real value. Otherwise, it receives 0 points, right? Sometimes people would say, of course, I will go the number of correct, I will go between 0 and 1 billion, and maybe you will get everything, of course. But the number of correct ranges that you have, right, you divide it by 10. For example, when I did this exercise, right, and I said, right, you needed the stated confidence to be 90%, right? This is what we need to do, to be 90% confident. And I think I mentioned it, but very briefly, you need to be 90% confidence, and it's totally fine. Don't worry. I'm going to do the exercise with me, right? The stated confidence is that you want to be 90% confidence that I am in my range going to include the real data. So the calibration rate, I made, for example, in my case, I had 6 good ones, right? 6 good responses. So I got 6 good responses. For example, I wanted to, for example, the Amazon River, I didn't do it well. Apple, I didn't know it was 3 trillion. I mean, that's overwhelming. Oil production, I didn't know. And I think that the Tokyo population, I never imagined that it was going to be like 37 million people. That's like 3 times my country. So, or 2.5. It's you cannot imagine things like that. So what happens, I only had 6 response. 6 divided by 10, of course, I have a 0.6 hit rate. That was my hit rate. And my hit rate, right, I have to divide it to see my calibration index by 90%. Why? Because the idea was that I have to be 90% confident that my low and high were going to encompass the real value. So if you do, let me see here, calculation, 0.6 divided by 0.90, let me see here, did I do it right? 0.6 divided by 0.90, yeah, it was 0.6, 0.6. So you see here, the interpretation of that is that if my calibration index is less than 0.70, I have a strong overconfidence, right? That means that my ranges more likely are too narrow, right? Because remember that I needed to have 90% confidence there for each one of them. Depending on the range that you have 0.7 to 90, moderate, overconfidence. You see, you should widen your ranges. Around 1, well calibrated, never got 1 ever. And 1.1 is underconfident. So this is for people that has very high ranges, right? So we're going to stick with this number, right? Maybe everybody can, I don't know, write down your number if you calculate it well, but that was the idea, right? That you have a number, right? That you have a number. And this is the first part of the estimation. We're calibrating you, right? We're calibrating you. Once we calibrate everybody, we're going to do, right? We're going to go to the second tool, right? And if you write to me, I'm going to include my email here. .com. I can send you the 2 things. I mean, the questions, of course, you can generate this with ChatGPT, but the main idea is that they are generalized questions, right? Not biased questions, but general questions. And the second thing that we're going to see, let me go back. Oops. I don't know what happened there. Oh my God. 1 second, please. The second thing that we're going to do, right? We're going to ask, now that we have the calibration index for every one of us, right? Let's say that we are a team of 21 people, right? Going to do an estimation exercise, right? What we need to do is we need to move from this weak elicitation that we're going to say here. And what we need to do is we have to estimate the impact of a risk. It could be, for example, even impact of an accident risk, right? So we're going to be only 3 experts here. And the main idea is that we need to move on from these weak elicitation processes where you have what is the estimate to a better elicitation. I would say what we need to happen for the high case. You see, we're thinking about the limits here, and then you collect independently these Cauchy assumptions, etc., etc. So we're going to move on to this best practice. For this best practice, I have this Excel sheet, right? Which is called EOE, Expert Opinion Elicitation. But we're not going to forget the number, the calibration rate, right? So let me explain this little sheet for you, which is very, very simple. Of course, I'm not going to do 20 experts, and I just did it for 3 because it's very simple to understand, right? So this is based, I think that the author is Cook, the one who generated this methodology, and of course I translated it, and I did it a long time ago with some clients that were experts on that as well. So the main idea is that you have an expert, and this 1 or 2 and 3 is each and every one of you, right? You have the experts. And what I do, and normally what the process is, of course, I have the impact of a risk here. Let's say impact of a procurement delay risk, impact of a flood risk, impact of a crack in a dam risk, anything that you can imagine, right? And what we do, and normally this is the process, right? Each one of us is going to have an estimation application, an estimation as a post-it. You can do it with a post-it, right? So not everyone is going to see each other's estimation, right? This is after that. So I will ask you to do it, and you will have min 8,000, 12,000, or 8 million, 12, and 20 million. Expert number 2, 5 to 15. Expert number 3, 7 to 25, right? But they don't see each other's answers. You see it because you have the sheet, but they are not seeing the answer, right? That's one thing. This is the process, right? Second thing is that in the weight here, this is where your calibration occurs, right? If you are a really good estimator, your weight is going to be higher, right? If you're not a really good estimator and you don't have the experience, maybe your weight is going to be lower. Let's say, for example, here that we have an expert here, and I can see my friend Quinton there. So he's going to be more like a 90, but I will put 40, right? So you don't overwhelm everybody. So 40, 30, and 30, like this, right? That means that his weight is going to be much higher than the others, right? Because he knows more and he's a better estimator. I was looking at, and there's a lot of formulas and a lot of work on that. It says that depending on the calibration rate that you have, there are a lot of alternatives to translate that into the weight here, right? So I just do it subjectively here for simplicity, but if you want to go deeper, you can go deeper and deeper and generate this model. So once you have this, right? This is and here this is one of the errors here. Once you have this, what people do is they, well, let's get the average of each one of them and create a distribution from that, right? That is one of the things that I've seen, and I remember that this is something that we shouldn't do. Or for example, take the mean of the mean, the max of the max, and then the average, and then generate another one. But what actually we do here, right? Let me see. We're going to take the means, the simulated mean, right, of each one of them, but the simulated mean, and we're going to take here the sum product of the distribution, you see, for each one of them, times the weight, and that is going to be the distribution that we're going to use. You see that it's not super difficult mathematics, not at all, but that's going to be. And here you have the minimum, the median, and the max. So that was another alternative. What I use to show the values is this error bars. So you see that you can have these error bars. You can show these error bars in Excel, which are really nice because they let you see how the estimations go to the right or to the left. Imagine that you have somebody, this expert here says between 10,000 and 20,000 here, right? So you see it moves to the right. So you see the bias of each one of them. And this is maybe 7,000 to 9,000. And you will see it's narrower, right? And maybe what you can do, you can change that, right? And then finally you can run this model. So the main idea is that you will have the estimations for each one of the experts. That's one. You will have a distribution. I set up this in advance using a PER distribution, right? The PER distribution, if you're familiar with that, has a minimum, most likely, and maximum like this. And it's going to be the one being used for the model. You can set it up with any distribution. They recommend it to be something smooth like a gamma or beta distribution, but I prefer the BERT just because of simplicity, right? Like this. And then you have the weight of each one of them. Then you do the sum product. So you see that it's not rocket science. You just do the sum product, and you can stay with this distribution. So what I will do, I will run a simulation with 1,000 samples, right, like this. And what this will do, it will create the distribution for the total, which is this, right? This is the weighted total. So this could be, and that's what the methodology says, right? This could be the distribution that you use for the input, right? So based on the distributions that we had here, that everybody set up, and after we weight those distributions, after we weighted this distribution, right, I will go there and then in 1 minute, right? With those distributions, right? What I can do, I can take the resulting distribution as the input in my model. That's the main idea. I will take it as the input in my model, right? How is it that Enda is asking me for E10? So E10 is the mean of this distribution. You see, I'm not taking the mean of this. I'm taking the mean of this distribution, right? Here, which is like 8 to 36. Let me show it to you here. 8 to 36, which is this, right? So that's what I took to do it, right? And this could be, and this is like the complete process. You see that it's not something too cumbersome, right? Because we just added this. Remember, you can do this with a post-it, and with a post-it, it works, right? Of course, they don't see each other's, so they don't have a bias. Mistake number two, you don't need, even let's say that I'm the moderator, I see everybody's distributions. Take a look here. This is expert number one. Take a look, expert number two, expert number three. Sometimes what is a good discussion, and it's when you, for example, estimate software, or it's like, why is it that for expert number two, was such a small impact, and maybe for expert number one, it was such a high impact like expert number three. Maybe you can understand, right, and say, well, why is it that your impact is so high? But it's not the idea to get consensus on the mean, right, and say, oh, so let's meet in the middle, right? Let's meet in the middle here. You're not there. But to discover why is it that you have such a variety. And that's the difficult part of it, right? Because maybe here, this is only because of experience, but maybe this person here was taking in consideration one event that was not related to it, but he was extrapolating it from a different industry. I had this experience before. So this is something that you need to find out, and of course, take a look and hopefully note, and not to try to move people to the center, right? This is not the objective of the exercise. The objective of the exercise is to find out what is the expert elicitation distribution that you have, right? In this case, I would go with this one, right? With the sum of the distribution, which is this, right? Right? And I think that this is the one. Let me see. I think that this is the one between 8,000, yeah, and 15. So I think this is the one that you got, right? Because of that. So this is, of course, I'm not saying that this is the way, but this is an alternative that I find very practical and very easy to implement. One very important thing, and this was the third aspect, is that you don't have to tell people their weight, right? I mean, it depends on who you're doing this with, but there are people very sensitive that, for example, let's say that Dan is the moderator, and he tells me, you know, Gustavo, you're a 5% in this process. So it's like, oh my God, why didn't you even call me, right? If I'm going to be 5% of it. You see that people has egos, etc., etc. So we have to be very careful about that. But this process, if done correctly, it really helps. And I've seen very interesting results there. So you see what we did, and then let me come back. Again, I put my email there. So if you want this sheet, and of course the presentation, more than happy to share it with you. You just write it. Maybe you can write it to me right now, otherwise you will forget, right? So we're now going to this 3-point estimate, right? We talked about the minimum, most probable, maximum. We already did that here, right? Minimum, most probable, maximum, right? And how is it that you can ask these things, right? And this is what I liked about this methodology, is that what is the practically impossible number that it's impossible to go below? So this is the lowest possible plausible bound. Or the most probable, you can ask what single value feels most typical, right? And the maximum, what value is practically impossible to exceed, right? Sometimes this is when you do maybe a per distribution where you have minimum and maximum, and that's why you ask what is value practically impossible to exceed. Sometimes people like to be asked with what we call a trigen distribution, right? With you have when you ask for P10, sorry, P50 and P90, for example, and you say what is the value that you are 90% confident that it's going to be, what's the value that you are, that it's lower, etc., etc. Oh, thank you, Efin Chukia. It's or Ilya. I imagine that it's your name. So thank you. It's a really interesting point, and we can go in so many directions here, right? So sometimes people feel much more comfortable instead of saying what's the value practically impossible to exceed because they don't know. Sometimes you use a trigen distribution where you ask for the percentage and you say what is the value that you know that you're 90% confident that you're never going to surpass. So the expert is going to give you P90 and automatically the software, whatever it is going to give you the limits, right? So this cushion is going to be automatically generated, right? So this could be another way to ask, and of course this is going to change the distribution here because here I ask for the minimum, most probable, and maximum, right? But you have different alternatives here. And thank you, Ilya, again for the comment. Yeah, very interesting, right? Now that we have that, remember we have the expert elicitation sheet. I explained that to you in a minute, right? And we have to go to section 2 because right now we have, well, the distribution selection here. I mean, the main thing that we have here are the parameters. That's what we have here. It could be any distribution. You see that after I run the simulation, 1 second. After I run the simulation, I have the minimum, most likely, and maximum here, but I didn't have the distribution type. I can use this, of course, I can generate the outputs. For example, what I can do here, I can insert the data list, right? I will see, you see here, all my outputs. I can select those. Let me select this, copy all, like this. Let me see if I can make it happen. Oops, I didn't copy that. 1 second. Like this, right? And I have that. And I have all my outputs that are going to be my inputs, right? In the distribution. So once I have that, right? Remember that what is the goal here? And that's, again, remember that this is for newbies. This is for new people that is in contact with Monte Carlo simulation. Because if you're doing this with, with people that are very, very experienced in this, perhaps the processes are going to be a little bit different. But the goal is not to have the perfect distribution, right? The goal is to have a transparent representation that can be updated when more data arrives. You see, is to give a good first step. Because you see what happens is that we just say, well, what is the impact of this? You have 3 experts and then you ask by email, you then average everything and send it. And with this, at least it's going to be much more appropriate, right? Now, again, as we have the distribution parameters, we have this minimum, most likely, and maximum. We have the ability, if we have historical data, again, right? That's going to support the decision. That's going to be great if you work in the financial industry or some type of operational industry where you have, information about failures, information about blackouts, downtimes, etc. Or if you don't have historical data, you can use min, most likely, maximum to build an expert-based distribution, right? After you do any of these two, you just validate and lock, right? The first one is the process, and this is what I use with this historical information. I just made up some historical information here and say, well, let's do a fit distribution on this, right? This is the information that I have. I click on add here and say, well, from the common distributions, I will try every common distribution here, a binomial, log normal, normal, etc. And if you like, you can try, I don't know, a per distribution, if you like, for example, here. And I think I already have a per, no, or univariate. Let's see if I have, well, let's say a Pearson distribution, I don't find it, gamma distribution, like this, etc. So this is going to try all the distributions that I like to try here, right? And it's going to give me the best one. That's what we do, right? That's what we do. And then I can insert it to a worksheet, for example, here. And for this particular cell, we're going to have the Vos Pearson 5 distribution that's going to replace all the historical information. Now, if I go back, you see here, this is what I did. I generated from this information here, I generated all these potential ones. And what I did, I can select what is going to be the criteria that I will use to select that distribution. It could be a chi-key, it could be chi-square, or it could be any maximum likelihood method that's going to optimize each one of these candidate distributions and make it the best distribution for my data, right? And of course, again, document the final choice. That's the main idea here, to document the final choice and say, well, we're going to use, because we have historic information about the impacts of this risk, and now that we have our limits, that this is the distribution type that we're going to use, right? And here we have the potential distributions that you can use. Beta PERT, default for 3-point estimates when a smooth bounded distribution is desired. Here I have another one. It's when a historical information analysis was done. For example, if you use AACE classes for cost estimation, you can use this. Triangular, when simplicity and transparency matter, and here, when you need extreme floats, right? Why is that? Because you will emphasize more on the extremes than in the center. Like, for example, if you do a per distribution, your center of gravity is going to be more into the center here, right? So that is why. You have a log normal for positive numbers, a beta for bounded proportions, etc. Right? So these are the things that you have. Now, here you have the same distribution selection reference for more distributions in case you want it. And we have what we call, and I like to always have this, which is called the visual validation, right? And the visual validation, what it does, it just lets you see if the distribution boundaries and the shape is good enough for you to represent the logic of your variable, right? Like, for example, here, please give me 3 seconds. Give me 3 seconds. I'm so sorry. There was a lot of noise outside. Hopefully you didn't hear it. So, for example, does the peak feel right? Right? Is the peak in the right? In the right? You see here, in the right range, like this. Is the tail highly credible? For example, here, should I expect a tail like this, or my tail here is okay? Right? Is the distribution too narrow, too wide? My P 10, 50, and 90 match my intent. Remember, this is my intent. 8 to 15, right? Is my reference value inside logical boundaries? You see that sometimes you have a reference cost, for example, that you say you cannot surpass that cost. So there's, for example, here the cost is going to be 17,000. That's the unitary cost, 17.5 thousand. And I mean, it's very unlikely that you will surpass that. So How much you have as a probability here? 15%. No, it's way too much. 15% of the time I am surpassing a value that my history says that I surpass 3%. So I will have to change the shape of the distribution. So you see what happens here, right? We are entering a world into that the distribution shape matters. If you do things, or if you select a distribution just by saying, well, this is a per distribution, without asking these questions, most likely the model, you know how it is, garbage in, garbage out. So the model is not going to be good enough, right? So that's why I wanted to include these steps here. So remember, from the first two steps, we got the calibration rate. Then with the calibration rate for every expert, we have the boundaries. With the boundaries, we're going to select the distribution, right? Here we're trying to select what is the best distribution. We are supported by historical information that we had before, right? So we need to see if our boundaries were there or not, right? Like this. Now, what else do we do? The final sequence and the results, right? On the advantages, right, what are the advantages of using this method? Now that we have the parameters, the distribution shape for all the relevant variables. So first of all, you see that there's no free lunch. This method is going to take some time. If you have 20 distributions, you will have this for 20 distributions. But the good thing is that you can do this remotely with the experts, and maybe you can do it in one session. Right? Sometimes they need more supporting information, right? And this is going to be the workflow, right? So bear with me for a second. You start, right? You map the owners of the variables, right? Who you're going to call. The 21, 22 people that work here, we are the experts. I need to call you, right? This is very important because sometimes people start to do the modeling, but they don't know who to call, and they generate variables that nobody knows how to estimate. That's one. We profile the experts. We do the calibration. Remember, with the questions about the Eiffel Tower, the Amazon, right? We do the elicitation of the ranges with the sheet. So we have that. We see this is one resource. This is another resource. And we select the distribution as we did before, right? With the preparation and calibration phase. And when we build the parameter table. Once we do that, when we have the parameter and the distribution, right? Each distribution for each relevant variable should be added to the model. That's the idea, right? Each one of the distributions should be added to the model. And then we integrate that, run the Monte Carlo simulation. We know the outcome of the Monte Carlo simulation, and then we run the sensitivity, and hopefully this is going to enrich our decisions. Why is that? Because we're going to have things that we didn't have before, like a confidence level, right? What budget or date gives us 80% confidence? What should management focus on first? Engineering, permits, execution, etc. What changes under stress? This one is a completely different world, right? What happens if I increase 5% my capex? What happens if I increase double size, let's say my warehousing capability? Or what happens if I increase my interest rate, my discount rate, because the things are not getting much more stable, or vice versa, right? What's the probability of exceedance of certain date or a certain number, right? And I will ask everybody to remember about this, right? About the sensitivity of this, because there are a lot of tornado charts here. You have correlation tornado charts, you have regression tornado charts, you have contribution to variance tornado chart, right? And my recommendation here, and with this I will finish because I know we are almost in the hour, right? Is that the contribution to variance, that's a very simple one, because each one of them comes into a percentile, for example, 0.5, 0.3, 0.8, 15, etc. And they all sum up 100%. So the tornado chart is just a coincidence, because you can also have something like this. I don't like pie charts, but maybe organizations like pie charts. So you can say this is 0.5, and this is engineering. This is procurement. Here, this is procurement, and this is, I don't know, permits. So what basically you're doing is, what is the level of responsibility for each one of the risks that you have, right? So that would be something that you could use, and that's my recommendation. Remember, this is for people that are beginning. Of course, you can explain later regression tornadoes and correlations, contribution to the mean or mean variance tornadoes. You have plenty of them. But the main idea, remember that the main idea of a tornado chart is to bring focus, to allocate resources or decisions or priorities, right? So that's the main idea of the tornado chart, right? So now that we have the complete, remember, the complete process, right? End-to-end workflow from the mapping owners to review the decision making after we went through all of this. So hopefully you will be able to go from the gut feeling of these owners that you have of the variables or you yourself, right, to review a decision making that was based on Monte Carlo simulation. And that was the idea of today's webinar, right? What are the main common mistakes that you need to avoid? One, using one optimistic point estimate, right? If you have a relevant variable that is replaced by a very optimistic point estimate, please discard it. That's going to do a lot of harm. Two, forcing consensus. Remember what I was talking about. Don't force consensus, right? Choosing normal distributions for variables that cannot be negative, right? Choosing a distribution upfront just because it's simple. Right? Ignoring the tail behavior. Remember what I just told you a minute ago. Do not ignore the tail behavior. Not documenting the assumptions. This is something that I've never seen. Right? Documenting the assumptions. It's very unusual that somebody documents the assumptions and say, well, this is why we did this, etc. And treating the sensitivity as a decorative chart. For me, the sensitivity analysis is normally the first chart. I don't show the histogram. I don't show the CDF, etc. No, this is for me, but I normally start with the sensitivity analysis, right? So just as a quick takeaway, I hope this was helpful for you to give you an alternative proposal on things to do to prepare Monte Carlo simulation models, is that start with a clear decision, right? What is it that you're going to do? Structure the expert judgment, which is something that we like. I mean, sometimes we like to do it, but we don't do it. So structure the expert judgment from the gut feeling. Remember, try to eliminate all the biases that you can, right? And select the distributions that match the story and use the sensitivity to focus the attention. That's what I would do with Monte Carlo simulation, right? To move from this gut feeling with this expert opinion to Monte Carlo simulation model. So please remember that Monte Carlo is not about predicting the future perfectly, but making uncertainty visible. That's the idea. And making the right uncertainty visible, manageable, discussable, etc. So thanks again for your time. I see that you're sending me some comments here. There's a lot of focus on cost in Monte Carlo. It could be used on duration and schedule. Yes, not a problem. Yes, you can do that. Beno, and maybe you can write to me and I can show you how to do it, because it's already 2 minutes before we need to finish. So I will take the question and respond it offline. More than happy to do it. You have my email, so more than happy to help you. And please remember that in our virtual sessions page, let me show it to you here. We have every month. We have these free webinars. We're going to have one next week about real estate decisions. So that's going to be really fun. And we have another one about mapping risk. So we have and this is going to help you maybe, Bino, to answer your questions. So thanks everybody for staying, and hopefully you had a little fun with the Q&A, and hopefully this helps with your processes.